Okay, let me do a couple of these problems for you. Number 43, if you can see, there's actually two triangles in the top, and it says both Derek and Sam are 5 feet 10 inches tall, and the basketball goal is 10 feet high. So let me just go and draw that real quick. We have a basketball goal, something like that. This is 10 feet. Then we have two basketball players. Let's draw that to the rim. One triangle and two triangles. And they said the heights of each of these basketball players, are 5 feet and 10 inches. So this has told us the angles are 43 and 29. So whenever we see triangle problems, we want to isolate the triangles and see if we can find anything about the sides of the angles. I see that I have two angles here, but I have no sides. In the end, if you read the problem is asking for how far are the boys standing apart from each other, so they're looking for this length right here. This length from here to here, that's the length they're looking for, which is not really a part of the triangle, it's a subtraction of the two. If I take the full length and I minus the little triangle, that gives me what's left over. So that's the big idea, that's what we're looking for. Now for any problem that we're solving for, we need at least one side of the triangle. Given these are right triangles, so we have an angle, we just need a side now. So let's find out what that third side is. The problem with feet and inches, it's that it's not like there's 10 inches in a foot. So we need to find a way. I'd rather not use decimals. So I'm going to change these all into inches. So 10 feet times 12 inches is going to give us 120 inches. And over here we have 5 feet times 12 is 60 plus 10 is going to be 70 inches. So the height of this part of the triangle, given the top here was 10 feet or 120 inches and the bottom here was 70, that distance is going to be 50 right between. So let's go ahead and draw this to make it a little bit easier to look at. We have one triangle coming up. We have another triangle coming up. We know that this side here is going to be 50 inches. We know the inside angle is 43 and this is 29. Now if you can see, that's actually a right triangle now, and we can actually solve for that triangle. But it's also, to make this a little easier for us to see again, if I draw this as two different triangles, we have our 43-degree triangle with a 50 inside, and then we have a longer triangle here with a 29-degree angle and a 50 inside. Okay. So our goal is to find these sides here, and when I subtract them, it'll give me what's left here. So for us to be able to solve for that side, we have the opposite, and we're looking for the adjacent. We have the opposite, and we're looking for the adjacent. How do I know it's opposite? It's because it's opposite of the angle here. And these are right triangles, so we do have a name for these three sides. And to use opposite adjacent, that's going to be tangent. So tangent, so 29 is equal to opposite 50 over our adjacent, and we'll call that A. Over here, the tangent of 43 is equal to opposite over adjacent, we'll call this A over here. Let's go ahead and solve it. A is equal to 50 over tangent of 29. I'll call that a hot swap, a quick swap. We can swap them out. A is equal to A's on top and then tangents on the bottom. Okay. Next thing we need to do, we just have to pull out the calculator. Let me get the calculator out. Here's our calculator. Show me an add. Okay, so we want to type, this is in degrees, I see degrees. So 50, let's clear it first. 50 divided by 29 tangent equals, that side is A is equal to 56.36, 53.36, and our next side is 50 divided by 43 tangent equals, that's going to be 53.61. Yep. So then let's find the difference between the two. 56.36, 53, 56.36 minus 53.61. And that tells us the difference between their heights, how far they're apart is 2.75 inches. So they're pretty darn close to each other. So when we look at these problems, the main goal is to try to come up with a right triangle. We can solve right triangles as long as we have one angle and one side, and it's a right triangle. Okay? All right, the next problem is find the exact value of each of the expressions. So we're going to use our unit circle here. We're going to just draw out the angle. Let's use the first one here. That's 4 pi over 3. Now 4 pi over 3 is greater than a pi, so we know we're going to be either in quadrants 2, 3, or 4. In this case, we're not close enough to get to quadrant 4. We're just 1 over 1 3 pi, 1/3 over a full pi. And the hint is if it's pi over 3, that's going to be a 60-degree angle, so I know that's going to be 60 degrees. If you want to change this into degrees, that's 4 pi, or 4 over 3 pi times 180 over pi. That's our conversion here, and that's going to give us 240 degrees. Now, since we know it's 180 and then extra 60, 180 plus 60 is our 240. Now, we should know our three sides given it's a 30, 60, 90 triangle now. So it's a 1, 2, square root of 3 in quadrant 3. Both adjacent and opposite are negative. So they want a cosine. What's the cosine of 4 pi over 3? So 4 pi over 3 is going to be, cosine is adjacent over hypotenuse. You should always verbally say it out or say it in your brain. So our adjacent here is -1 and our hypotenuse is 2. Let's look at a harder one. Let's look at 29, the cosecant of 390. So 390 is bigger than 360 by 30 degrees. So we know we're going to take one full circle and a little bit more. That's going to be our 30-degree angle. Oops, it's not straight. So 30 degrees. We know it's a 30, 60, 90 triangle. 1, 2, square root of 3. Both being positive in quadrant 1. Right, this is coterminal with 30 degrees. That means, 390. Whether I draw 30 degrees or 390 degrees, they stop in the same spot on the unit circle. And for this, the cosecant is hypotenuse over opposite. My hypotenuse here is 2 and my opposite is 1. So reduce to 2. Now, the next question here, they're giving us points from algebra 1 pretty much. So if I look at problem number 2 here, -6, comma 6, that's our x and our y value. So that's going to be left and down. X is -6, and y is left and up. So that's what the point is. So we got a triangle here. So our height is 6, now our x value is -6. And find the third side, it's Pythagorean theorem. 3 squared plus 2 squared equals 2 squared. So it's going to be 6 squared plus -6 squared, which should be positive, so we would minus 36 plus 36 is 72. And then the square root of 72 is our c value, which is really 36 times 2, right? And that's going to be square root of 36 is 6 left over 2. It turns out this is a 45-degree triangle, 45, 45, 98, and we could have predicted that to be 6 square root of 2. Now they want us to write the sig trigonometric function, so they want us to go through sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and tangent of theta. So sine is 6 over 6 square root of 2, which is 1 over square root of 2, being rewritten as square root of 2 over 2 by rationalizing the denominator. And we're just copying our trigonometric identities, like opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay. All right, the next one is actually the hardest. Here we are going to use what's given, and then what's given here is the characteristics of this angle. So we know tangent is positive, and sine is positive, and cosine is positive. So what quadrant is tangent positive, cosine positive, and sine positive? All students take calculus, which are a way of telling when stuff was positive. Everyone's positive in quadrant 1, and cosine is positive in quadrant 4. Everyone's positive in quadrant 1, and sine is positive in quadrant 2. And tangent and everyone's positive in quadrants 1 and 3. Okay? Alright, so what are we looking for? We're looking for tangent being positive. So we're either going to be here or here. Of these choices, we also want sine to be positive. So sine is positive up here, and then cosine also be positive. So we only have actually one choice here. This triangle here meets all our criteria. So we're going to fill out this triangle. They told us the sides of this triangle, tangent theta is equal to 2. Well, that's an invisible one on the bottom, and tangent always stands for opposite over adjacent. So opposite is 2, adjacent is 1. Now, is this a square root of 3? No, this is not a special 36-9 triangle. Let's go and use Pythagorean theorem. 1 squared plus 2 squared equals a c squared. All right, we're using Pythagorean theorem because once you know two sides, you can always find the third missing side. And we don't know what the hypotenuse is. 1 plus 4 is c squared. C squared is equal to 4 plus 1 is 5. C is equal to the square root of 5. So now we know what the third side is. Now we can square root of 5. Now we can figure out the rest of the sine, cosine. We already did tangent. That was given to us that was 2, but we can prove it. And you're going to come up with cosecant, secant, and cotangent. Okay. So let's just verify all our steps. Sine is opposite over hypotenuse, which can be rewritten with a square root on top. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, which is exactly what we wanted, right? That's exactly what we want over here. All right, that's it.